Hello, my name is Benjamin Day. I'm a senior systems engineer with Paessler. Been with the company for about 3.5 years now. Before that, had a wide array of jobs in networking, from network engineering to administration to help desk to all that fun stuff. I'm here today to talk about PRTG and Paessler as a company. When we talk about, who is Paessler, we're a company based out of Nuremberg, Germany. We have just over 200 people working worldwide for us right now. We started in 1997 in what we'll call the garage phase, where we were literally a small company out of our CEO's house, just kind of getting going. Around 2001 is when things really started to take off. That's around the time that the software really started to get a name for itself, really started getting going. Between 2003 and 2007, it's where we started being known more for PRTG than Paessler as a whole, and that's also when we decided to move into PRTG as it's known today. Before, it was just a couple of different programs with a bunch of add-ons, but then it became PRTG as the whole as we know it today. And then from that point forward, it's been just a bottle rocket of all kinds of things. I used PRTG before I started working for the company. When I used it, it was a shadow of what it is now. There's so much more now than was in it just 3 years ago. So with all that, unless anyone has any questions, I'll move straight into the environment. So when we say what is PRTG, this is PRTG. This is the web interface for PRTG. It's a network monitoring tool. It runs on Windows platforms. You can install it on Server 2008 R2, 2012 R2, or 2016. We recommend 2012 R2. Just from our internal testing that we've done, it seems to perform a little bit better on that than it does on the others. It can be physical or it can be virtual. It doesn't matter what hypervisor you run it on. If you're going to run it virtually, after about 5,000 sensors, you might want to consider upgrading to a physical host. If you run on a physical host, once you get up to about 10,000 sensors, that's where you really need to kind of step back and get in touch with one of the SEs at Paessler to really talk about how it's architected, so we make sure if you're going to go past 10,000 that it'll perform the way you want it to.
One quick question.
Yeah.
Because there's a pretty wide breadth of network monitoring. When you say sensor, are you meaning like end host or client, or what do you mean by sensor?
So the way we define a sensor is a metric that we want to follow on a device. So a port on a switch, that's a sensor. The CPU on a server, the memory on a server, the disk on that same server, okay. Those are all sensors.
Gotcha.
The really easy way to visually illustrate that is everything you see here, these little guys, these are all sensors. So this installation here has just shy of 1,400 sensors. That's about the median install size that we see for most of our customers. We can monitor everything from Windows hosts to networking devices, storage arrays, your hypervisors, environmental monitors, power PDUs, battery backups. If it's got an IP address and if it's got a way of getting on the network, we can monitor at least ping on it. And there's a lot of things out there that I'm finding, downstairs that have SNMP stacks on them, so we can get a lot more out of them than just ping. The basics of network monitoring with PRTG fall into basically two categories. It's SNMP and WMI. That's the majority of the sensors as they fall with PRTG. A lot of these sensors here, you'll see they either fall into that category of SNMP or WMI. SNMP sensors comprise mainly your switches. So when I come here to these Cisco switches and HP switches here, all the traffic that I'm able to monitor on those interfaces, these are all SNMP sensors. They're very low cost when it comes to resources, but they yield a lot of useful information. So if I look at this interface here on this switch, I don't just get bandwidth. I get my bandwidth in and bandwidth out broken up so I can see my ingress and egress. But I also get unicast packets per second. I get multicast packets per second. I can see broadcast packets per second, as well as errors and discards. Now, just like I have on the traffic in and traffic out, I can set thresholds on those. So it's not just this ambiguous number that comes in, it's a metric that you can watch and get alerted on the high or the low.
So I see there's actually just on this one interface, there's quite a few different metrics. Are those all sensors,
No.
or the interface is just a sensor?
The interface is just a sensor. We refer to these as channels.
Okay.
Channels are not counted against you. Channels are included in the sensor. So when we say, 100 sensors in our freeware, you're not getting just 100 metrics. You're getting closer to maybe 500 or 600 metrics on average. Because one sensor is not just, there's very few sensors we have. I think only maybe 5 or 6 we have that are one-to-one. Most of them are one-to-many, where one sensor brings you multiple metrics within that sensor. When we talk about WMI, WMI is used for mainly Windows. It'll resolve simple things like CPU load, so I can see here my total CPU. I can see each CPU thread broken out. So in this case here, it could be either 4 cores or it could be dual core hyper-threaded. We don't look into whether it's a thread or a core. We just give you the logical processing unit. In addition to simple things like CPU, disk, things of that nature, some of the other things I can get into would be services and processes running on a machine. So if I wanted to see that, I'm going to cheat here a little. So I'll go to this WMI service here. So this is a WMI service sensor. With this, I can look at any sensor running on that Windows machine. Doesn't matter what it is. And I can also see that it's running. I can see CPU usage. I can see working set of memory, so I know how much physical memory it's occupying. I can see handles and threads, and I can also see page file usage, how much virtual memory it's occupying. With this right here, I can really hone in on those third-party applications that may not have any other easy way to hook into them. I mean, most of them may have an API where you can, do some PowerShell coding or something like that, or Python or something to get in and get metrics out of it. But at the very least, this is an easy way to be able to see how that application is behaving on your host and how much resources it's utilizing. I can do the same thing with processes. The only difference with a process is because it's multi-threaded, or I'm sorry, not multi-threaded, but it can be multi-instanced. I track the total number of instances as well. So you see the same information here. You see working set of memory, you see CPU usage, but we have CPU usage total and averaged out per instance, as well as handles and threads, private bytes, and then instances. So again, since we're looking at processes, it's a nice way to be able to see how many instances of itself that it's spawned. It could be a precursor to an event that if a certain application starts spawning multiple processes of itself, that could be a sign that it's a problem that needs to be addressed. So you can set thresholds on that. Same thing with CPU or working set of memory or anything like that.
Can you do things outside of SNMP and WMI?
Yes, we can do, we have SSH-based sensors, we have SOAP-based sensors for VMware, we can do WBEM. We also have an API where you can develop your own sensors that will return any metric you want. So with the API, you can write your own custom sensor in any language that you're comfortable with. And we have an example of the JSON or the XML that we need to return. So real quick, I'll just show you over here on custom sensors. And all the way down at the bottom, this is the XML that we want it back in, the structure that we recognize. And then here's the JSON that we expected to come back in. So a really easy thing I've seen a lot of with PowerShell is that you can get your data and have it stored as variables, and then you can just spit out results in this exact XML format, and it comes through perfectly. I mean, you can get multiple channels and their values and everything, and it comes through as a nice multi-channel sensor. So you're not just getting one metric, you can get multiple metrics with this. In fact, a lot of the PowerShell sensors we have are based on this. They just return XML. And a lot of the third-party PowerShell sensors that have been developed by users out there work the same way. It just returns a XML as the result.
Do you have a repository or community on your site where we would find all that?
Absolutely. So on our website, under the support section, we have a new link for Script World.
Sounds appropriate.
So with Script World, you can select what system type you're looking at, what language you prefer it's in, if it's a particular vendor, or you can just search for it. So I could say scripting language, PowerShell. and I could just hit search on that, and I'd see all my PowerShell sensors. So 48 of them match it. Some of these are already built into PRTG, and if it is, we have a little tag that says PRTG native script. So if you're searching for it on script world and you didn't know it was already built into PRTG, here's how you would find out, and then you would know, oh, I can just go add that right now. If it's not in PRTG, we give you a link to get to it. It's either a KB article where we've included it as a response to something, or we give you the GitHub for the person that's written it. We do not post anything until we have thoroughly checked to ensure the integrity of the code. So we're not going to put anything up here that's going to hijack a system or anything like that. We make sure that it does what it's intended to do before we sign off and allow it to be up here.
You monitor changes in the repos?
Yes, we get updates on the repositories, and when it comes out with a new version of it, it's checked to make sure, and then it's re-added to script world.
Okay.
Yeah. We talk about the PRTG approach to network monitoring. Our approach is scaling horizontally. That's the biggest part of it. That and adding sensors for things that are important. And I know that can sound a little ambiguous, but let me embellish on it a little bit. When you talk about network monitoring from the very get-go, if you're with a company and you sit down and the manager's like, we have no network monitoring, we need network monitoring, how do we do network monitoring? Of course, the initial response is we have to monitor everything. We need a system that monitors everything. We want to know when anything happens. We want to be able to track everything. But if you start to think about that, that's a little daunting and it's a little useless. Do you really want to track the access layer switch that's connected to all your end users? Do you really want to get an alert when Bill from accounting undocks his laptop and takes it into a conference room because that switch port's now gone down? Do you really want that level of alerting? In most cases, no. So you have to start thinking about, what do I want to get? What are the things that are important to me? And then start monitoring from that aspect. All your mission critical servers, all your mission critical switches. Things that aren't that critical, look for the critical things on them. So when we talk about access layer switches, let's just monitor the system health. Let's monitor the uplinks. And then maybe let's monitor the interfaces that are going to things like printers, cameras, access points, devices that can be circumvented if somebody got physical access to the building that shouldn't have physical access to the building. Past that, when it comes to what you're monitoring on that device, don't waste a sensor on something that's always going to be green. Monitor things that you expect change in, because otherwise it's just a waste of a sensor. Disk space on a multi-terabyte volume that you're not storing large data on. Okay, it would take years to fill it up at the rate you're going. If you want to monitor it, monitor it every 24 hours. Don't waste the CPU resources on it. The processor on a mission critical server, okay, yeah, maybe we monitor that every 30 seconds because this is handling a very important aspect of our business, and we want to make sure if it gets throttled that we have a really we have quick telemetry on that so that we can get in there, take care of the problem before it becomes a really big problem. One of the more common ones I see is making sure that users set up bandwidth monitoring on their gateway device. Going in and setting up thresholds that are meaningful to that interface, like I've done here on this interface here. In most situations, your traffic in and traffic out are going to be metered differently if you're using like a commercial cable connection or anything like that. So set them appropriately. Don't just go with a blanket statement for everything.
You have multi-tenancy, so like if I don't want to see the server guys stuff, I only want to see the network stuff.
So everything's role-based.
Okay.
When you go to set up that, you build a user group first. The user group can be tied to Active Directory, so you can give it an AD user group, and then anyone that's in that user group can sign into PRTG with their AD credentials. And then once you've got the group that you want, you bind that group to a group on the device tree, so that when they log in, all they see is that group or groups. Same thing would apply from an MSP standpoint. If you have an MSP that wants to be able to leverage PRTG to monitor customers, they can do the same thing with that. To where when their customers log in, they only see their data and no other customers' data.